All right. Number 1 is negative 4x equals negative 20. So if you feel comfortable doing this, like without me, then you are ready for the exam if you're getting the right answer. And remember, the exams are all multiple choice in this class. So we have x being multiplied by a negative 4 set equal to negative 20. So you just want x alone in this case. So we're just going to divide by negative 4. This was way back at the beginning of this unit. Negative 4 divided by negative 4 just turns into 1, right? So we have x is a negative divided by a negative becomes a positive, so it's no longer a negative number. And then 4 times 5 is 20, right? So 20 divided by 4 is 5. So for number 1, x is 5. Here, if you get
presentation folders.
Hold on. All right, here, if you get something like 5x equals 5x or 0 equals 0, that would be all real numbers. If you got something like 1 equals 2, something that's never true, that would be no solution. Those are the only reasons you would use B or C in this case. But that's not going to show up on our exam. All right, number 2 is x minus 2.1 equals 3.3. Good. So this is the same thing, but with decimals. And here we were doing the opposite of multiplication. Now we're doing the opposite of subtraction. So the opposite of subtraction is addition. We're subtracting 2.1 from x, so we're going to add 2.1 to both sides. Those cancel. You just have x on the left. 3.3 plus 2.1. If you line up the decimals, you could just add them the way you would add something without a decimal. 3 plus 1 is 4. 3 plus 2 is 5. So 3.3 plus 2.5 is 2.1 is 5.4. So here, sorry, I could be writing. The first one was x is 5. The second one is x is close to that, 5.4. All right, here, you're not going to see a decimal question with the distributive property, but it's just a good opportunity to get more comfortable with decimals and more comfortable with the distributive property. But this sort of question will not be on the exam. 1.4 times the quantity 8 minus x. You will see the distributive property and you will see decimals, but your decimals will look a bit more like this. They will not be together, those two concepts, on this exam. All right, 8 times 1.4, I just suggest you use your calculator. We know how we're doing it, but it doesn't matter whether or not you can do it by hand, in my opinion. So 1.4 times 8 is 11.2. 1.4 times x is just 1.4x, but there was a minus sign, so it's actually a negative x. So negative x times a positive 1.4 becomes negative 1.4. Equals 1.2 times 6. Again, I would just use my calculator. 7.2. And then negative x again times that decimal is just minus 1.2x. Can't tell if this is blurry or not. Always is. Always is though, isn't it? All right, so I would say, oh, not done. All right, now you have this term, a term with a variable, a constant, and another term with a variable, but they're on different sides of the equal sign, right? So we can't just combine these two. We actually have to move this one across. You can either move the 1.4 to the right or move the 1.2 to the left. It doesn't really matter. We traditionally move the letters to the left, but it's easier if you have a positive x. So you could take the bigger number, since they're both negative, and move it. So I'll add 1.4x. I decided that because I don't want a negative x, but you would get the right answer if you moved them the other direction. Good. So that's 11.2. Keep the equal sign, 7.2. Negative 1.2 plus 1.4 is also just 1.4 minus 1.2, right? And it's just 0.2. Or you could write 0.2 if you like that better. Good. All right, so we've moved the x. Now I need to move the 7.2 away from the x. So we're combining 7.2 and 0.2x to be sure you can kind of switch their places. That one was a positive. This one doesn't have a negative in front of it, so it's also a positive. So that's just another way to look at it. You're adding 7.2 to whatever this is. Okay. So subtract 7.2, subtract 7.2 from both sides. Here, I still have that equal sign between them. Here is 0.2. Sorry, I forgot to add that x. I was just switching their places. So that's just a copy of that. I just forgot the x. 11.2 minus 7.2. 2 minus 2 is 0, right? So it's no longer a decimal. 11 minus 7 is 4. So 4 equals 0.2x. Good. We started with distributing, and then we moved to combine like terms. And now we have 4 is 0.2x. So x is being multiplied by 0.2, right? If I want to undo that, I need to divide it by 0.2. Anything I do to this side, I also need to do to this side. Dividing by a decimal, oddly enough, sorry, will make your number bigger. So don't worry if that happens. You did not get the wrong answer. You are dividing by a number that's smaller than 1. So it's like multiplying by the inverse of that number. 0.2 is 1 over 5. This doesn't matter. This is definitely not on the exam. 0.2 is 1.5. So 4 divided by 1/5 is the same as 4 times, sorry, 5 over 1, or 4 times 5. So x is 20 for number 3. Number 4 says solve the equation for A. There is no reason that there's an asterisk next to that question. It just means that I pulled that question from a different textbook. They're not worth any more or any less than other questions. All right, we have the number A, which is the same as the number x, being divided by 2, set equal to 4. So I still want to do the opposite of whatever's happening to A to get A alone. So it's being divided by 2. To cancel out being divided by 2, I need to multiply it by 2. Anything I do to that side, I'm going to do to this side. You are also welcome to call it 2 over 1. If you feel more comfortable multiplying a fraction by a fraction, you can call it that, or 2 times A over 2. Either way, it becomes 2A over 2, right? And then 2 is being multiplied by A, and anything that is a factor on the top and a factor on the bottom, you can cancel out, and you can just call it A. So the reason we decided to multiply by 2 is so that we could just cancel out the 2 on the top and the 2 on the bottom of the fraction. So we have A on this side, and then 4 times 2 is 8. Is that okay? So that becomes A equals 8. It's only one step. It looks a lot like number 1. So let's look at number 1. Number 1 was negative 4x equals negative 20. We know that was being multiplied, and so what we did was we divided by negative 4, not the x. And we got x is positive 5, right? 4 is the same style of problem. It's one single step, but instead of an x, you have an a, and most importantly, is instead of a multiplication problem, you have a division problem, but you're still going to do the opposite. So you're going to multiply. Do you see how those are similar? Here we divided by what was being multiplied. Here we're multiplying by what was being divided, and we got a equals 8. So just because it's a fraction doesn't mean it needs to be less understandable than something that is a multiplication problem. The fraction just means it's a division problem. And what did we say it was? 8? 4 times 2 is 8. All right, here's a 2-step. 9x minus 10 equals 80. So we're going to both add and divide, right? You always want to do your addition or subtraction before your multiplication and division when you're solving. It's the opposite of order of operations, which like didn't go over that great on the last exam. So you're doing the opposite of order of operations. 80 plus 10 is 90. Now you're going to divide by 9. Divide by 9, x is 10. Good? All right. Solve the equation, check the solution. So number 6, I think this is the one where I put up several, even though there's only going to be one question. I just want you to see different versions. Like if there's a negative in front of the x, what should I do? So we have negative x plus 7 equals 12. Another way to write this would be 7 minus x equals 12. Okay, those are the exact same equation. Now, this x has a negative, but am I subtracting 7 from it, or am I adding 7 to the negative x? If you look at this one, it's very obvious that we're adding the 7, right? But here it's kind of hard to tell. So just because the first number, there's a subtraction sign between the first and the second term, does not mean that this is negative, okay? This is still a positive 7 minus x. So to undo 7 minus x equals 12, we are not going to subtract, or sorry, we're not going to add 7, we're going to subtract 7. Okay, because that's a positive 7 right now. We still have the negative x, and then 12 minus 7 is 5, right? Negative x equals 5, but I'm not trying to find negative x. I'm trying to find x, so I'm going to divide by negative 1. Divide by negative 1, because anything divided by 1 is itself, but negative divided by a negative becomes a positive. Positive divided by a negative becomes a negative. So basically just changing both of those signs so that the x is positive. Good. All right, number 7. So that was x is negative 5. Number 7 is 2a plus 6 equals 6. I chose this one because if we subtract 6, we get 2a equals 0. That doesn't mean stop. That doesn't mean that you got the wrong answer. That doesn't mean that there's no solution. Keep going, just like it was any other number, okay? 0 divided by 2, you can even put it into your calculator. 0 divided by 2 is just 0. 2 divided by 0 is when you have a problem, okay? But you can take 0 and divide it by any number, and it remains 0. And that is not the same as no solution, okay? It's just a is 0. That would not be the same as that. If we have x equals 0, that goes here. That is not no solution. Good? All right. Number 8 asks us to write as an equation. You guys remember that really long one you did? Twice the difference of a number and 9. But remember, the difference of and are together, okay? So the difference of x and 9 means x minus 9. The difference of goes here. It was just waiting to get those two numbers out. The difference between x and 9 is equal to 3 times the sum of, ooh, this is hard. The sum of the number and 8. Good. So twice means I'm multiplying 2 times x. Ooh, twice the difference of, sorry, that means parentheses. So if you see the 3 before, so if we said twice x minus 9, that would be that, right? But twice the difference means we're going to put it in parentheses, and 3 times the sum means we're going to put it in parentheses, okay? So if you see the word for the operation before you see the letter, put it in parentheses. But this is just practice for expressing sentences as equations, right? So the equation would be 2 times the quantity x minus 9 equals 3 times the quantity x plus 8. Just make sure you feel comfortable with the parentheses. Only use the parentheses if 3 times the sum of, okay? 3 times the sum of looks like this. 3 times a number plus 8 looks like this, okay? So if you see number first, no parentheses. If you see the operation first, put parentheses around the whole operation, okay? Here we saw the operation first, so we put parentheses around the whole operation. And then the number is, so now you want to solve it. So 2, sorry, we definitely don't have room for that. It was 2 times x minus 9 equals 3 times x plus 8. Good. So 2x minus 18 equals 3x plus, what's 3 times 8? 21? 24. That's like one of the ones I never remember. All right. Move the x's. I'm going to move the x over here so it's positive. Negative 2x, negative 2x. 3x minus 2x is just x plus 24 equals negative 18. So I will subtract 24, negative 18 minus 24 is negative 42. Good. You're not going to see something that difficult on the exam. So the number is x equals negative 42. Number 9 was another example like that. Number 9 says twice the sum of, so again, twice the sum of negative 4 and a number. The sum means plus, so twice the sum of negative 4 and a number is the same as that same number decreased by 3/4. So the equation is 2 times the quantity negative 4 plus x equals x minus 3/4. Okay? You're not going to get a fraction that you're going to have to solve. But if we were to solve this, 2 times negative 4 plus x equals x minus 3/4. 2 times negative 4 is negative 8. 2 times x is positive 2x equals x minus 3/4. I'm just going to call 3/4 0.75, okay? So negative 8, we can say plus 0.75, right? So we have now negative 8 plus 0.75 is negative 7.25 plus 2x equals x. Now I'm going to subtract the 2x from both sides. Negative 7.25 equals negative x. If I divide those both by a -1, I get x equals 7.25. Because a negative divided by a negative is a positive, negative divided by a negative is a positive. Do not worry, you will not get something where you have to solve with a fraction, adding or subtracting a fraction with a whole number. Number 10 asks us 4 times a number subtracted from 9 is twice the number. 4 times a number subtracted from 9 is twice the number. 4 times a number subtracted from 9 is twice the number. Good. All right, we'll subtract 9. No, don't do that. There's only 9 on this side. Add 4x, add 4x. So we're just solving for x. So we keep the 9 because that was a mistake. Equals 6x. Divide by 6, divide by 6. 9 6 equals x. Or if you put that, you can divide 9 by 3 and you get 3. You can divide 6 by 3 and you get 2. So 3/2 equals x. These are very difficult. The ones on the exam are not going to be that difficult. And if this is overwhelming you, don't like shut down on the whole lesson, all right? I'm not good at those either, and that is fine. So 11, we have x is less than or equal to -8. Good. All right. They just want it on the number line. And then in interval notation. So these, I do admit, are not multiple choice because the graph will be multiple choice, but the interval notation will not be multiple choice. It'll look just like this on the exam. So half multiple choice. So here's -8, -9, -7, right? Less than or equal to -8. The equal to means it's going to be a bracket, and the less than means it's going to go towards the left. So I'm going to choose B for that because the equal sign means it's a bracket and the less than sign means it's going in the negative direction. In interval notation, remember that means -infinity if you have an arrow going to the left, and then it stops at -8 and it has a bracket, so you write the bracket. Here we have y is greater than or equal to 4. So these are all at 4. Because of that equal sign, it's a bracket. So it's not C and it's not B, right? Greater than is going to the right. So it's going to be the letter D. It's greater than 4 or equal to 4. So in interval notation, that's going to be a bracket with 4. And it goes on forever. So that's positive infinity. Both infinities always have only parentheses, no bracket. Here's another one. Now we need to solve for x, okay? It was -2 is less than 2 times x minus 3 is less than or equal to 4. Good? All right, let's distribute the 2. This remains -2 is less than 2x minus 6 is less than or equal to 4. Good? All right, to solve for this, we want to add 6, not just in the middle, but to both sides. So there's 3 places to add 6. Here it cancels. We are left with 2x in the middle. Keep the signs the same. 4 plus 6 is 10. 6 minus 2 is 4. Good. Now We still just want x alone in the middle. So we're going to divide by 2, divide by 2, divide by 2. 4 divided by 2 is 2. 2 divided by 2 is x. 10 divided by 2 is 5. Okay, now think about what this sign means, right? So we have a less than sign and then a less than or equal to sign. You can also flip this around. X is greater than 2. Okay, that's not going to be this one. 2, 2, 1. It's not going to be that one. Does the 2 get a bracket or does the 2 get parentheses if I got x is greater than 2? It looks like it's C, right? Because greater than or equal to, greater than, right? And then x is less than or equal to 5. They're both less than or equal to 5. So it's just C. That was our only choice, was the 2. Good? All right, and then in interval notation, just look at the one you chose and write it as a pair of numbers or the infinity symbol. Good? All right, here's another solve and check. Negative 16 equals x plus 10. You just want to subtract 10. Subtract 10. Negative 26 is x. X is negative 26. Here's one with more than one step. I'll write it here. 9x minus 9 equals 5 plus 7x. Good? All right, so you have a 9x and you have a 7x. It doesn't matter. You could move the 9 by subtracting 9 from both sides or move the 7 by subtracting 7 from both sides. I'm going to move the 7 just because I want my x to be positive, so I'm going to move the smaller number. 7x minus 7x, that goes away, so I just have 5 on this side. 9 minus 7, 2x, minus 9. Good. Now I want the x alone, so I'm going to move that 9 over here by adding it. I'm going to do the opposite. 2x equals 14. Divide by 2, divide by 2, x is 7. So here I'm going to say the solution is x equals 7. And another fraction. Solve the equation and check. 0.3x minus 4 equals 1.1x minus 16. Here I'm going to move the smaller number over. Negative 4 equals, again, I just encourage you to use your calculator. 1.1 minus 0.3 is just 0.8. Now you can move that 16. Plus 4 is 20. 0.8x. Now remember, we're going to divide by 0.8, and it's okay if your number is bigger than 20. Okay? 20 divided by 0.8 is 25. So it is possible you might have to do that much decimal work on the exam. Here we have 5x plus 18 equals 2 times the quantity 2x plus 4. Yes. All right, what? Oh, you're right. I'm sorry. Thank you. 16 minus 4 is 12. 12 equals 0.8x. Divide by 0.8. Divide by 0.8. 15. All right, so I should have subtracted 16 minus 4 is 12, not 16 plus 4 is 20. Thank you. X is not 25, X is 15. Here we're going to distribute that 2. 2 times 2 is 4x. 2 times 4 is 8. Now we're going to decide what to move. I'm going to move the 4 because I want to keep the x positive. So the 5x is bigger, so I'm going to move the 4 because I have to subtract it. 5x minus 4x is just x. That's nice. X plus 18 is 8. So now I have to move that 18. It's being added, so I'm going to do the opposite. X is negative 18 plus 8. So you're kind of subtracting, but for a negative, right? So it's negative 10. Negative 18 plus 8 is the same as 18 minus 8, but then the answer is negative. All right, this is hard, and there will be one on the test, okay? I gave you 3 examples of it, so we'll do 3 examples with the fractions. Don't be scared. Remember, we already saw one of these, and it just means divide, okay? But if you have more than one, it means divide. And to get rid of this 5, we need to multiply everything by 5, right? To get rid of this 3, we need to multiply everything by 3. So instead, let's just see what is 5 times 3, right? Because to get rid of this 5, I'm going to multiply this by 5, this by 5, and this by 5. To get rid of this 3, I'm going to multiply this by 3, this by 3, and this by 3, right? So everything is going to be multiplied by both 5 and 3. So it's going to be multiplied by 15. So you find if you have 2 different numbers, I would multiply them together only on the bottom, right? If you have 2 different denominators, I would multiply them both together and then multiply everything by that number. Any questions? So when you see a fraction, think of division, right? And then try to find a number that you can divide by 5 and get a whole number, and divide by 3 and get a whole number. So 5 times 3 is 15. So we're going to take 2x over 5 and multiply it by 15. Multiply it by 15. So every part of this, we're going to multiply by 15. Good? All right. I know it's a lot. Very a lot. 15 times 2 is 30x over 5 minus 15 times x is just 15x over 3 equals 15 times 4 is 60. Okay? And the reason we did that is so that we could cancel out these fractions. So just now, because of the number we chose, we can take 30 and divide it by 5, and it will not be a fraction anymore. 30 divided by 5 becomes 6. 15 divided by 3 becomes 5. Leave 60 alone because there was no fraction ever, right? 4 was never a fraction. So now you just have an x minus an x. 6x minus 5x, you can just combine the like terms. 6 minus 5 is just x. X is 60. Good. Also, if you're completely lost, you can just say, what is 2 times 60 divided by 5? 24, right? So you can just plug these in. So that would be 24. 60 divided by 3, 20. 24 minus 20 is 4. So that's correct. So you could just go down the list and plug each of these in for the whole x in every part of the equation, see which one's right. 9t divided by 20 equals t divided by 4 minus t divided by 4 equals 1. All right, here we multiplied everything by 15. Here you can just multiply everything by 20. Because 4 is a factor of 20. If I take 9t over 20 and multiply it by 20 minus t over 4 times 20, sorry, I get right sideways. Right? Those cancel exactly, right? And so I'm just left with 9t minus 20t over 4 equals 20. Now, if I take 20 and divide it by 4, I get 5. So that becomes 9t minus 5t equals 20. 9 minus 5 is 4. Divide by 4. I get t equals 5. Good. All right, so here we chose the number 15 because I can take 15 divided by 5, 15 divided by 3. Here we chose 20 because I can take 20 divided by 20, 20 divided by 4. Here we have the numbers 4 and 2 to get rid of. So I'm going to multiply them both by 4. Everything over here gets multiplied by 4. Everything over here gets multiplied by 4. Okay? So we have 4 times 2x minus 5 over 4 plus 4 times x for that guy equals 4 over 1 times 2x plus 5 over 2 plus 4 times 6. That was just me wanting to continue, but I can't. Here, 4 cancels 4, and I have 2x minus 5. 4 times x, oops. 2x minus 5. 4 times x is just 4x equals 4 divided by 2 becomes 2. So that becomes a 1 on top, right? This becomes a 2 on top. So now I'm just saying equals 2 times 2x plus 5 plus 4 times 6 is 24. So that's in parentheses. 4 divided by 2 is 2, so I'm multiplying it by 2. Don't worry, you will not have to do that in the exam. But this is good practice. Now we're doing like terms. 2x and 4x is 6x minus 5. That becomes 4x. That becomes 10. And the 24 stays the same. 6x minus 5 equals 4x. I can combine these into 34. Good. I'll just subtract the 4x. 6 minus 4 is 2. Add the 5. 34 plus 5 is 39. So I would just call x 39 halves. Sorry. Good. (21) says the sum of, there will be one of these on the exam. The sum of 3 consecutive odd integers is 171. 3 consecutive odd integers is a number, that number plus 2, that number plus 4, right? Consecutive means they're in a row. Odd means it's not each one, right? We skip one each time. So 3 consecutive odd integers. 1, 3, and 5, right? So if x equals 1, then I represent this as x. I represent this as x plus 2, and I represent this as x plus 4. That's if they're odd integers. If they're just consecutive integers, this should be 1, 2, 3, right? If x is my first number, then I represent them as x, x plus 1, and x plus 2. The sum of 3 consecutive odd integers, so here are my odd integers, and I'm going to sum them, is 171. Find the integers. Good? So 3 consecutive odd integers, x, x plus 2, and x plus 4 are 3 consecutive odd integers. Why do the odd integers add even numbers? I agree. Because if you think of any, because it's 2 because we're skipping one. Like odd integers could be 9, 11, and 13, right? They're in order, they're consecutive, and they're odd. So it was, why do the odd integers add even numbers? If this is 9, to get to the next odd number, I have to add 2 to 9. To get to the next odd integer, I have to add 4 to 9. Okay? On the exam, it's not going to say even or odd. It's just going to say consecutive. Okay? On the exam, it's only going to say consecutive. So this says consecutive odd, so I'm adding 2 and adding 4. But if it said consecutive, I would just say x, x plus 1, x plus 2, okay? That's important to understand. So, yeah, you have to add 2 to get to the next odd number, then you have to add 4 to get to the third odd number. If I add these 3 consecutive odd integers, I get 33, right? So I'm just going to make this up. If I sum these, I get 33. Let's solve for them, okay? You're just now combining like terms. X plus x plus x becomes 3x, right? 2 and 4 becomes 6. Right? Now we're just solving, so subtract 6. 3x equals 33 minus 6, 27. Divide by 3, divide by 3. X is 9. Right? So what are the consecutive odd integers? 9. The next one is 9 plus 2. The next one is 9 plus 4. Is that okay? So you have to set up an equation, find x, and then use x to find not only x, but the next 2 numbers, okay? So in this example, it was actually those 3, whatever x is, the next one, and the one after that are going to be equal to 171 when, right? When I sum them. So I have to add all of this together. So I'm doing the same thing as I did with 33, but my answer should be 171. So it should still be x plus x plus x is 3x, and 2 plus 4 is 6, but we're setting it equal to 171 now. Good. We're still going to subtract that same 6. 3x equals 171 minus 6. It should just be 165. Divide by 3. Divide by 3. X is 165 divided by 3, 55. But remember, they want all three numbers. So they want 55. They want the next odd number. And then they want the third odd number after that in a row. Good. Remember that on the exam, they're not going to ask for odd or even. They're just going to say consecutive. So it's not going to be x plus 2 plus x plus 4. It's going to be x plus 1 plus x plus 2. All right, number 22. In the last year, a total of 16,674 earthquakes occurred in a country. Of these, 88.5% were minor tremors with magnitudes of 4.9 or less on the Richter scale. How many minor earthquakes occurred in the country in the last year? How many minor earthquakes occurred? Okay. In the last year, sorry. 16,674 earthquakes total, of which 88.5% minor. Okay, so make sure you know how to label what that statistic is. Okay, how many minor earthquakes occurred in the last year? Is that the percent they gave us, or do we need to subtract that percent from 100? Right? 88.5% are minor, so that means 100 minus 88.5. That means 11.5 were major, right? Because there is a possibility that they ask you the opposite of the percent that they actually provided you. Okay, how many minor earthquakes? 88.5% were minor. So I think we're okay. Now it's just a matter of changing 88.5% to decimal. 0.885. Good. So we're going to say 16674 times, because if it was 100%, right? The decimal for 100% is just you move the decimal spot 100% to decimal. You just move that decimal place to the left 2. 100, it was here. It goes to the left 2. 1, 2. 1.00, right? So 100% of 16,674, 100% of 16,674 is 16,674 times 1.00, right? So 88.5% of 16,674 is 16,674 times 0.885. Not divided by. 1,400, 756. 0.49. Does that look like 80% of that number? Yes, it does. The number of minor earthquakes was, round to the nearest whole number, 49, you're gonna round down. But don't worry, it's multiple choice. 1, 4, 7, 5, 6 minor earthquakes. Number 23, a large western state consists of 4,631 million, don't forget that million, okay, acres of land. 11% is federally owned, okay? Don't ignore the million. Don't ignore the million. Find the number of acres that are not federally owned. So before, in our last question, we had minor earthquakes and the percent they gave us was minor and they asked for minor. However, here they're saying 11% is federally owned. They're asking for not federally owned. Okay, so you can either call that a percent or you can find that percent and subtract it from your whole. Either way, you're fine. Okay, so number 23, just like we did 22, we have 4631 M. Okay, don't leave off the M because the multiple choice questions might say your answer with the word million and then your same answer without the word million. And you need to know whether or not to include the word million. Okay, so we have 4,631 million acres of land. 11% is federally owned. So 11% of 4,631 million is 4,631 million times 0.11, right? We just move that decimal place. The decimal place was right here. We move it 1, 2 places, so we get 0.11. 4,631 times 0.11. 509.41. Million, remember, units, million acres. That's only 11%. That's what is federally owned. What is not federally owned? So not federally owned would be 4,631 million minus 509.41 million. $4,121.59. If you were to round that, if it's 5 or higher, you round it to the next highest number. So you're saying 4,122, don't forget the million. Good. Or you can say 11% is federally owned. What is not federally owned? 100 minus 11%. So 89% is not federally owned of 4,631 million is 4,631 times 0.89, which is 4,121.59. So it's just two different ways to get that same number. You can find 11 and subtract it from the whole, or you can take 89, which is 100 minus 11. Good. Just make sure you know whether they want that percent or they want that percent subtracted from the whole. 24 asks you to graph the inequality on a number line. Write an interval notation. So x such that x is greater than or equal to 44.7. That equal to means it's going to be a bracket, right? And greater than means it's going to the positive direction or going to the right, going towards infinity, right? So it's not going to be a parentheses because of that equal sign. It's not going to be going to the left. It's not a negative, it's a greater than. It's not going to be going to the left. It's going to be a bracket, right? And remember, when you need to write an interval notation, you just look at your graph that you chose and read it from left to right like an English sentence. So I see a bracket at 4.7, and then I see an arrow forever. So that means it's going towards infinity. Infinity gets close parentheses. Number 25 asks us to graph the solution set of x such that negative 23 is less than or equal to x. I like to flip it around. X is greater than or equal to negative 23. Good. All right, x is greater than or equal to negative 23. Again, that equal sign means it's a bracket, so it's not going to be this one, and it's not going to be this one. The greater than symbol, which direction is greater than on the number line? It's that way, just like the symbol, right? So greater than negative 23. It's at negative 23, it's got a bracket, and it's going in the positive direction. Now when I need to write it in interval notation, I just look at the one I chose. It starts with a bracket at negative 23, and it goes on forever. Good. Graph the solution set of the inequality on a number line and write it in interval notation. So x such that 4 is greater than or equal to x, and x is greater than negative 3. So I'm looking for the number line between 4 and negative 3. Would it look like this? That is not how 4 and negative 3 work on the number line, right? Negative 3 is before 4 on the number line. Okay? Negative 3 is before 4 on the number line. That means I need to flip this entire inequality around, or just say x is greater than negative 3 and x is less than or equal to 4. Or you can flip the whole thing around. Negative 3 is less than x, which is less than or equal to 4. Okay? Because when I try to put 4 on the number line and negative 3 on the number line, it doesn't work out the way I usually see it. So I want to flip the whole inequality. Flip the signs because it's negative 3 is less than x, if I was reading that backwards, is less than or equal to 4. So less than negative 3 means it'll be a parentheses, so it can't be this one. And less than or equal to 4 means it'll be a bracket, so it's C, because it's not 3 and 4. And the negative 3 does not have a bracket, so only the 4 has a bracket. The solution set is, what did I pick? Parentheses, negative 3, 4 with a bracket. Number 27 says 9x minus 9 is less than or equal to 8x minus 8. Good. Move the x's. This is 9x, this is 8x, so I'm going to subtract the 8x because it's smaller. 9x minus 8x is just x. Add 9 to both sides. X is less than or equal to negative 8 plus 9 is the same as 9 minus 8, which is just 1. X is less than or equal to 1. So the equal sign means it's going to be a bracket. Means I can eliminate all of those, right? And it's not 2 brackets, it's just 1. I only have negative, or I only have 1. I don't have 0 and 1, right? I only have the number 1, and I have x is less than 1. Less than is that direction, in the negative direction. So I'm going to choose A. X is less than or equal to 1, so the solution set is from negative infinity to 1 with a bracket. Solve the following inequality, graph the solution set, and write an interval notation. Negative 5x is greater than or equal to 15. I'm going to divide by negative 5, divide by negative 5. Remember, when you're dividing by a negative, you have to flip the sign. So that sign becomes less than or equal to. Negative 5 divided by negative 5 leaves us with x. 15 divided by negative 5 is a negative 3. X is less than or equal to negative 3. Because of this negative, we flipped the sign, okay? Because of the equal sign, we know it's a bracket, so we're going to eliminate anything that doesn't have a bracket. It's either A or B, right? Because they both have brackets at negative 3. X is less than negative 3. Less than is that direction, so it's B. The solution set is from negative infinity to negative 3. 29 asks us to solve the inequality and write it in interval notation, no graphing. 7 times the quantity x minus 3 means 7x minus 21 is less than 4 times 2x is 8x. 4 times negative 1 is negative 4. 7x minus 21 is less than 8x minus 4. I'm going to move the 7x, but you can move whichever one you want. You'll still get the right answer. Negative 21 is less than x minus 4. I'm going to add 4, add 4. Negative 21 plus 4, you're subtracting 4 from 21 and making the answer negative. 17, so it's a negative 17 is less than x, or x is greater than negative 17. In interval notation, here's negative 17, x is greater than negative 17. So you can graph it on your scratch paper just to get a good idea of what your interval notation is going to look like. Good. All right, number 30 says, sorry. It just feels so crooked. Negative 30 says, or sorry, 30 says negative 11 is less than or equal to 9x minus 11, which is less than or equal to 16, right? We will solve for x. So x is negative 11 is being combined with x. So we're going to add 11 to all the sides. Negative 11 plus 11 becomes 0. Don't be afraid of 0. It's okay. Just treat it like any other number. Is less than or equal to 9x, which is less than or equal to 16 plus 11 is 27, right? Now I'm just going to divide everything by 9 because I want to get x alone. 0 divided by 9 is still 0, less than or equal to x, which is less than or equal to 3. We're just writing in interval notation, but it's easy for me to graph it if I have to put something in interval notation. So because of that equal sign, I need to use brackets. So bracket, bracket, between 0 and 3. So that's my graph. My solution set is just a copy of my graph, 0, 3. All right, the last 4 examples are just absolute value equations. So we got through the inequalities. We have the absolute value of 2x minus 7 is equal to 15. Good. Now, if you have isolated the absolute value on the left-hand side, that means that now you can take off the absolute value symbol and just write everything that was inside the absolute value set equal to your original positive number and set equal to the additive inverse, which is a negative of that term. Good. So 2x minus 7 is equal to 15 and 2x minus 7 is equal to negative 15. Now just go ahead and solve it. Solve them each, just like any other equation. 15 plus 7 is 22. 2x equals 22 divided by 2. X is 11. 2x minus 7 is negative 15. Add 7. Add 7. Remember 15 and 7, but the signs are different, so you're subtracting and you get a negative 8 is equal to 2x. Divide by 2, divide by 2, x is negative 4. So my answer here is x is negative 4 and 11. 32 was absolute value of 8x plus 9 equals 25. So I'm going to subtract 9 from both sides. 25 minus 9 is 16. The absolute value of 8x equals 16. Now I have isolated the absolute value, so I'm going to turn it into two different equations. 8x is 16, the original equation, and 8x is negative 16 are my two possibilities. Divide by 8, divide by 8, x is 2. Over here, we'll solve it. Divide by 8, divide by 8, x is negative 2. So my answers are x is negative 2 and 2. (33) similar. The absolute value of 2x plus 1 is 21. So first thing I need to do is isolate everything that's within the absolute value bars on one side alone, right? So I'm going to take that plus 1 and do the opposite. I'm going to subtract 1. So that I'm left with the absolute value of 2x equals 21 minus 1 is just 20. Now, absolute value means it's the distance from 0, right? So it could be positive 20 or it could be negative 20. So we're going to take that same 2x and set it equal to 20 and negative 20 at the same time. Sorry, divide by 2. X is 10. Over here, same thing. Solve for x, divide by 2. X is negative 10. So x is negative 10 and 10 for 33. (34), last one. The absolute value of 4n plus 6 plus 18 equals 4. So we have 4n plus 6 plus 18 equals 4. Again, we want to we want to isolate this on one side. So we're going to subtract the 18. And we get the absolute value of 4n plus 6 equals negative 18 plus 4 is a negative 14. Remember, absolute value cannot be negative. So this is no solution.